Hello everyone, I will continue with the risk and return. Last time we couldn't finish the whole chapter, so we'll complete the rest of this concept. So last time we talked about risk and return. So we defined couple return concepts. We talked about return, average return, geometric average return, arithmetic average return. We calculated portfolio return. We calculated return under uncertainty, and then we talked about risk. We learned how to calculate standard deviation uh, under certainty versus under uncertainty, and also we talked about risk of a portfolio or the standard deviation of a portfolio. Um, so if you have only two assets in a portfolio, we use this formula, if you remember, to compute the portfolio risk. Here I'm showing you some special cases. If the correlation between the two assets is -1, this would be your portfolio return. So significance of this would be you could actually create a zero risk portfolio if the correlation is -1. On the other hand, the other extreme is if the correlation is 1, you can take the whole expression out of this square root as w1 sigma 1 plus w2 sigma 2. In that case, the significance of this would be there is no diversification. That means portfolio standard deviation is just the weighted average standard deviation of the assets that makes up the portfolio. That means no risk diversification. Typically the correlation is not 1 or -1. Typically is between 0 and 1, and because of that you get some diversification. In other words, portfolio standard deviation is going to be less than the weighted average standard deviation of the assets that makes up the portfolio. So we talked about the diversification. So I said there is no diversification if the correlation is 1, but typically correlation is not 1, so that means some diversification is possible. So if we take the total risk and we can separate it into two parts, one is called diversifiable risk or unique risk, the other one is called undiversifiable or systematic risk, also market risk. So in other words, if you take a bunch of assets, put in your portfolio, your portfolio risk is gonna go down because of the diversification. Your portfolio risk will decline, but after a certain point adding more assets is not gonna help. So that means you will hit a wall that the risk is not gonna go below that level. So this risk is systematic or persistent. It doesn't go away, but the other risk, which is unique risk, can be diversified and can be eliminated. So because of this simple result, typically diversifiable risk or unique risk is not prized or not rewarded. The only market risk is rewarded, because since you can diversify this, there is no need to be rewarded. So therefore we don't use the total risk when we calculate required return, but only use market risk because of that. Because it's diversifiable, we don't give any reward for that. So we can talk about efficient frontiers. Efficient frontier is the gives you the best return for a given risk. So if we take the standard deviation as a risk and put in the horizontal axis, and if you take the expected return in the vertical axis, and then the relationship is here, so this efficient frontier gives you the best return for a given risk. So any asset under this frontier would be overpriced. That means they don't give you enough return for a given amount of risk. So that's why they are inefficient. So efficient frontier is the best possible case you can find. That means you can consider different options, but this would give you the best return. So that's called efficient frontier. So anything above efficient frontier is not possible. because there is no asset better than that. That's why it's called efficient frontier. So, but anything under efficient frontier would be inefficient. So therefore, as an investor, maybe first thing to do is you want to find assets on the efficient frontier because that gives you the best return for a given risk. You can do even better if you combine efficient frontier with a risk-free asset. You can even achieve better returns in most parts except just one point. So as you can see, this black line here is much better than efficient frontier, which is this line here, at every point except the point M. That's tangency point or tangency. So otherwise this would be even better than the efficient frontier. So you can combine risky asset, efficient frontier, risky assets, efficient frontier with a risk-free asset, so you can do even better. So now all you need to know is what is this point M. So you will hold a combination of M and risk-free asset. That's called capital market line. This is called capital market line. So we need to find a measure for the systematic risk, because as I said, only systematic risk should be used in pricing. So you can do a simple regression and you can find the coefficient of that single variable regression. In this case, market return going to be your independent return, assets return unit going to be your dependent return. If you do a regression like this, then the coefficient of this regression is called beta, and that beta is going to be used to price the assets. So this is called required return, and this model is called capital asset pricing model. So this gives you a relationship between risk and return. That's the whole idea of this chapter, that we want to find a relationship between return and risk. So that's the relationship we're gonna use between risk and return. So as you can see, higher the risk, higher the return here, and the risk measure is the beta, which is totally depend on the only undiversified or market risk. It's not total risk. So the beta is average beta of all assets is 1. The market portfolio has a beta of 1. So risk-free investment will have 0 beta. Assets with the betas between 0 and 1 are considered defensive stocks because their movement in response to change in macro factors are small compared to the market portfolio. On the other hand, assets with beta bigger than 1 are considered aggressive assets. So in other words, if market goes up and down by 10%, these assets gonna go up and down, let's say 20%. So that means they are more aggressive to move compared to the market. So how do I use this model? So this is called capital asset pricing model. So the capital asset pricing model is equal risk-free rate plus the beta, return on the market minus risk-free rate. So remember, we saw this before, right? Right here. This is the model. So it's pretty simple. So we will take the risk-free rate, in this case is 3%. And by the way, typically we use T-bill rate, 3 months T-bill rate as the risk-free asset. So the beta is 1.3. Return on the market. So this whole thing is called market risk premium. So that's 8%. So the required return in this case 1.3 times 8% plus 3, so 13.4%. So that's 13.4% is the required return. So let me do another example. Let's assume the expected rate of return on the stock is market is 14.5%, 10-year treasury. So we use the 10-year treasury in this example as the risk-free rate, which is 5.5%. The beta is 1.2. Market return is 14.5%. So based on CAPM, required return is risk-free rate 5.5 times plus the beta 1.2 times 14.5 minus 5.5. So that's 9% times 1.2 plus 5.5, 16.3%. That's the required return. Typically we would compare required return with the expected return. So expected return here is 25.8%. If expected return is higher than the required return, you would say this is a good buy. So let's do the next one. The question here is calculate the expected return for both stocks A and B. Calculate the required return for both stocks. Which one is a better buy? That's what we need to do. So we kind of combine everything we learned so far. So expected return for A. Remember, this is uncertainty case. So the probability of the normal economy is 25%, and the stock return in the Boston economy is minus 12. 45% chance it's a normal economy. In that case, return is going to be 25%, and 30% chance it's going to be a booming economy. And 30% chance is going to be 45. So let's calculate the expected return for A. 25, so that's going to be minus 3%. So the expected return for A is 21.75%. So let's do the same thing for stock B. Exact same thing. So 25% chance is going to be minus 5%. 45% chance is going to be 12%. 30% chance is going to be 22%. So expected return for B is 10.75%. Now let's calculate the required return for both stocks. Required return for A would be using CAPM. So here risk-free rate is 5.5%, and the beta for A is 1.8. and expected return for the market is 14%, minus risk-free rate is 5.5. So that's going to give me a required return. 14 minus 5.5, 8.5 times 1.8 plus 5.5. So required return is 20.8% for A, and required return for B is same risk-free return. The beta for B is 1.1, and this number is going to be the same. So 14 minus 5.5 times 1.1 plus 5.5. So that's 1485%. So now we compare expected returns with the required returns. Actually, something is called alpha. Alpha A would be expected return for A minus required return for A. So expected return for A was from here 21.75% minus required return is 20.8. So it's positive 0.95%. So in other words, expected return is higher than the required return. So we will call this a good stock to invest or good buy. So let's do the same thing for stock B. Alpha for B is equal expected return for stock B minus required return for stock B. Expected return for stock B is 1075 and required return is 1485. So this is not a good buy because expected return is lower than required return. So minus 4.1. So that's no. So that's yes, that's no. So stock A is a good buy and stock B is not, because based on the risk you take, you need at least 20.8% for stock A, and you get more than that. That's good. Here stock B, you require at least 14.85% based on the risk you take, but this investment gives you only 10.75%. Obviously you're not going to be happy with this result, so therefore this is not a good investment. So maybe we can do something similar. So again, we will do a similar example. Why don't I copy the whole slide? Copy. Okay, same question, same type of question. So we will have these stock A and B. If each scenario is equal or likely, find the expected return on the market portfolio and on each stock, etc., etc. So we will start with the expected return for all of them first. So expected return for the market is minus 5% plus 15% plus 32% divided by 3. I'm dividing by 3 because they are equal or likely, but if there are probabilities like this, like in the previous question, you multiply with the probabilities. If it is equal or likely, you just divide by 3 or 4, how many returns you have. So 10, 42 divided by 3, that's 14%, right? 14% for the market return. Expected return for stock A would be 5 plus 10 plus 18 divided by 3. So that's 28, 33, that's 11%. And expected return for stock B would be 32% plus 18% plus 56 divided by 3. So that's 50, right? 50, another 50, 106 divided by 3, 106 divided by 3. That's 35. I'm sorry, I totally messed up this one. Minus 15 plus 25 plus 56% divided by 3. Yeah, I mean, I should look at this way, right? So that's gonna be 10. 66 divided by 3, that's 22%. So we computed the expected returns. Now we will compute the required returns. Required returns. Required return for A. So this is gonna be question B. Required return for A would be risk-free rate, which is 5% risk-free rate, plus the beta. Stock A's beta is 0.7. And we computed return on the market as 14% minus risk-free rate. So 963, 11.3, right? 14 minus 5 times 0.7 plus 5. Yes, 11.3%. That's the required return for stock A. Required return for stock B, same for risk-free rate. The beta is 1.8. This part is the same. So 1.8 times 9% plus 5%, that's 21.2%. Okay, so let's calculate alpha. Alpha for A is the expected return of A minus required return of A. Expected return of A is here 11%, right? 11%. Required return is 11.3% minus 0.3%. Not gonna happy with this result. Alpha B, expected return on B minus required return on B. Expected return on B is here 22%. Required return is 21.2%. That's equal 0.8%. That one is good, right? Has a positive alpha, that means expected return is higher than required return. So stock B is a better buy. So that's that. So I hope this has been useful. So see you next time.